Okay, so as I said, there are lots of applications of parabolas. Um, One of them is in telescopes and the way the lenses are. So their mirrors are shaped like a paraboloid of revolution, which means we take a parabola, which is two-dimensional, and we rotate it until we get a mirror that is convex or concave, depending on which surface we're using. Another application is satellite dishes that are also shaped like paraboloids of revolution. So in this problem, we have a satellite dish that's shaped like a paraboloid of revolution, and the signals that emanate from the satellite strike the surface of the dish and get reflected to the single point where the receiver is located. That single point where the receiver is located is the focus. And I remember that by thinking it focuses the signals from the satellite. So the dish is 10 feet across at the opening and 4 feet deep at its center. So draw a sketch. Use the origin as the vertex. So here's what we have. We know the vertex is right here, and we know it's 4 feet deep. So the surface, the top is right here of our dish. And it says it's 10 feet across. So if it's 10 feet across, that means it has to be 5 to either side of the vertex because the vertex is always in the center. So we go to +5 and -5, and this is 4. So here's our satellite dish, more or less. And somewhere up here is where our receiver is, I guess. Don't mind my bad pictures. So, what do we know about this? Well, we know it opens up. And we know that the vertex is at 0, 0. And we also know that the receiver should be placed at the focus. Since it opens up, we know our general equation is x minus h squared equals 4a times y minus k. Since the vertex is at 0, 0, we really, though, just have h squared equals 4a times y minus k. The question is how, sorry, not y minus k. K is also gone. So just 4a times y. We need to figure out what a is. So how are we going to do that? Well, we know for a fact that this blue point right here is at 5, 4. So let's just plug in, and then we'll see if we can figure out what a is. So we plug 5 in for x, and that equals 4a. Y is 4. So 25 equals 16a, which means that 25 over 16 equals a. So that means, remember, a is the distance from the vertex to the focus. So the focus, where we put the receiver, is 25/16 feet, because we're measuring things in feet in this problem, above the vertex. Okay, that concludes 7.2. In the next set of videos, we'll start talking about ellipses.